In this video, I'm going to wrap up our minimum viable decentralized exchange by adding methods that allow users to deposit and withdraw liquidity. If you haven't watched the two previous videos that cover all the steps leading up to the DEX that we see here, I recommend watching those videos first. In the first part of this video, I'll give a brief description of how liquidity pools work in Uniswap. In the second part, I'll show you how we can add liquidity into our own DEX at the correct ratio. In the last step, I'll add the code for depositing and withdrawing liquidity to our Solidity contracts, redeploy them, and then demonstrate how the deposits work in the UI. So how do liquidity pools work in Uniswap? To initialize a pool, a depositor will deposit equivalent values of Ether and an ERC20 token. Therefore, an exchange contract will hold some amount of Ether in its balance and also some amount of ERC20 token. As a liquidity provider, how do I add liquidity to an existing pool? Uniswap offers a method called add liquidity. As a liquidity provider, I'll call that method and pass in some amount of Ether. The DEX will accept that Ether and then calculate an equivalent number of ERC20 tokens based on the exchange rate. For example, let's say the DEX holds Ether and Dogecoins. If I add 1 Ether into the DEX as liquidity, the DEX will use its automated market maker to calculate an equivalent number of Dogecoins based on the current supply of Ether and Dogecoins held by the DEX. When the DEX calculates that number of Dogecoins, the DEX will then transfer that number of Dogecoins from my own account into the DEX. Therefore, the amount of Ether that you pass in as liquidity should be about 50% of the total amount of the assets that you want to add into the liquidity pool. As we can also see in the Uniswap documentation, liquidity tokens are minted to track the relative proportion of total reserves that each provider has contributed. In real DEXs, the exchange rates are constantly changing as people are always swapping tokens and depositing liquidity into the DEX. Therefore, Uniswap also offers additional arguments that you can use when making a deposit. For example, max tokens, which specifies the maximum number of tokens that you want to deposit along with your Ether. The deadline specifies the time within which you have to make the deposit. This way, if the exchange rate changes drastically, you won't be surprised if you make a deposit that makes you deposit more tokens than you expected. This leads to an interesting question. Who decides the exchange rate? Every DEX can have its own exchange rates. Before the first depositor ever makes their deposit, the liquidity pool is empty. The answer is that arbitrageurs basically correct the price until the exchange rate on that DEX matches the exchange rate on all the other DEXs. If the exchange rates don't match, then the arbitrageurs will take advantage of that and trade until the balances in the DEX match the balances in the other DEXs. As a concrete example, let's say we have an exchange for Ether and some stablecoin such as Tether, which is supposed to be pegged to the US dollar. Therefore, 1 Tether equals $1. When creating the liquidity pool, let's say the first depositor deposits 1 Ether and 1 billion Tether. The actual price of 1 Ether is nowhere near close to $1 billion. Therefore, this is an arbitrage opportunity. The ratio of Ether to Tether is 1 to 1 billion. This means that if I pass in a small amount of Ether, I'm going to get back 1 billion times as much Tether back. As an arbitrager, I would execute this as many times as I can, as long as I keep on getting back more Tether than the Ether that I put in. As the arbitrage continues, the balance of Ether will increase and the balance of Tether will decrease as everyone continues trading Ether for Tether. Eventually, the balance of Ether and the balance of Tether in the DEX will reach some equilibrium such that the exchange rate of Ether and Tether will match that of other decentralized exchanges, and then the arbitrage will stop. For more details, I highly recommend that you read the Uniswap documentation. The first liquidity provider sets the initial price of the pool. They are incentivized to deposit an equal value of both tokens into the pool. If their deposit ratio differs from the current market rate, then there's a profitable arbitrage opportunity. In Uniswap and many other DEXs, when you make a deposit into the liquidity pool, you get back liquidity tokens as a result. When a depositor wants to withdraw their funds, then they burn the liquidity tokens and return in exchange a proportional amount of the total liquidity in the pool. Let's see how deposits of liquidity work. When depositing into a liquidity pool, you have to deposit equal amounts of both assets. For example, let's say the pool has 5 tokens of token A and 5 tokens of token B. This means that if you want to deposit some amount of token A into the liquidity pool, you also have to deposit the same amount of token B. However, it gets more complicated when the current balances in the pool are not equal. For example, let's say there are 3 tokens of token A and 6 tokens of token B. If you want to add 1 token of token A, how much of token B do you also need to add? As a clue, you can see that the supply of token B is twice as much as the supply of token A. Therefore, you should be expected to add tokens in the ratio of approximately 1 to 2. The exact math is that you can take the ratios of reserve B over reserve A and multiply that by the amount of token A that you're adding in. In our example, we are adding 1 token of token A into the pool. The total reserve of token B is 6. The total reserve of token A is 3. Therefore, 1 times 6 over 3 is equal to 2. Therefore, for each token A, we have to add 2 tokens of token B. We can simplify the previous expression like this. Let's say we want to swap token A for token B. We divide the supply of B by the supply of A. The supply of token B is in the numerator, which means that as the supply of token B increases, the numerator increases. That means the more of token B that you have in the DEX, the greater the number of token Bs that you need to add to the liquidity pool for each amount of token A. Going back to the minimum viable exchange tutorial by Austin Griffith, we are now ready to add these methods to provide liquidity for our DEX. There's one method to deposit liquidity, and there's a second method to withdraw liquidity. Back in our Hardhat project, I've added these two methods into our DEX contract. For an overview of the existing code in this DEX, I recommend watching my 2 previous videos, because in this video, I'm only going to focus on the deposit and withdraw methods. Our deposit function is payable, which means that depositors can call it and pass in some amount of Ether. Our DEX will take that amount of Ether and then calculate the appropriate number of ERC20 tokens that also need to be deposited. Ether reserve is the current balance of Ether in the DEX. Token reserve is the current number of ERC20 tokens that are held by the DEX. To calculate the exchange rate and the number of ERC20 tokens that also need to be deposited for that number of Ether, we're going to use the token reserve in the numerator and the Ether reserve in the denominator. This is exactly what I explained a few minutes ago. As the token supply in the DEX increases, that means that a greater number of tokens need to be deposited into the DEX for each unit of Ether. Once the DEX has calculated the appropriate number of tokens, then the DEX will transfer those ERC20 tokens from the depositor into the DEX. This function also updates the total liquidity to keep track of how much liquidity was added by that user. In Uniswap, the depositor would receive some number of liquidity tokens in exchange for their deposit. However, in our simplified deposit method, we're simply going to return the amount of liquidity that was minted. Our withdraw function works in a very similar way. When the depositor calls withdraw, they'll specify the amount of liquidity that they want to withdraw. The function will divide that amount of liquidity by the total liquidity and then return the proportional amount of Ether and ERC20 tokens. For example, to determine the amount of Ether that is returned during the withdrawal, the function will divide the input liquidity, or the amount, by the total liquidity, and then multiply that by the total Ether balance. To calculate the number of ERC20 tokens to withdraw, the DEX will take the input liquidity and then divide that by the total liquidity, and then multiply that by the total supply of tokens held by the DEX. In the last steps, we're going to update the total liquidity mapping and then also transfer the Ether and the ERC20 tokens back to the depositor. I've redeployed the smart contracts and relaunched the React app. The balance in my account is currently 0 Ether and 10 balloons. The DEX has 3 Ether and 3 balloons. First, I'll get some Ether into my wallet. Now I have 0.05 Ether and 10 balloons. At this point, the ratios of Ether and balloon tokens in the DEX are equal. See, the Ether balance is 3. I can also verify that the balance of the DEX in balloon tokens is also 3. This means that when I make a deposit into the liquidity pool, I have to deposit equal amounts of Ether and balloons. I'm also going to approve the DEX to take away my balloon tokens. Now that I've given the DEX an allowance to take away my balloon tokens, let's try depositing 0.01 Ether into the DEX. The exchange rate is 1-to-1, so the DEX should also take away 0.01 balloon tokens from me. As expected, I lost 0.01 Ether and 0.01 balloon tokens. Now let's make this more interesting by making the balances of Ether and balloon tokens in the DEX unbalanced. I can make the supplies of the assets in the DEX unbalanced by swapping balloon tokens for Ether. This will decrease the amount of Ether in the DEX and increase the supply of balloon tokens in the DEX. Let's swap 5 balloon tokens for Ether. Because the DEX only has about 3 balloon tokens and 3 Ether in it, because of slippage, I should get much less than 5 Ether in exchange for these 5 balloon tokens. After the swap, my total Ether balance is 1.9, and I now have only 5 balloon tokens left. Now, the balance of Ether in the DEX is no longer equivalent to the balance of balloons. Right now, the DEX has 1.1 Ether. The DEX also has 8 balloon tokens. Therefore, the ratio of Ether to balloons is 1.1 to 8, or approximately 1 to 8. This means that if I deposit Ether into the DEX, I need to also deposit approximately 8 times that number of balloon tokens. Therefore, if I try to deposit 0.5 Ether into the DEX, I also need to deposit 8 times 0.5 balloon tokens. 8 times 0.5 is 4, so I should see my balloon balance decrease by 4. Let's try this out. As expected, my Ether balance decreased by 0.5. In addition, I lost 3.5 balloon tokens. Thank you for watching, and please give a like and subscribe if you learned something. I also want to give a huge shout out to Austin for this terrific tutorial. If you have any questions about decentralized exchanges or DeFi, please leave them in the comments, and I hope to see you in the next video.